In this video, we're going to derive the sum and difference identities. So on the trig function sheet, that's these identities here. So there's sum and difference identities for sine, cosine, and tangent. Okay, and so to do this, all we need to do is derive one of these identities from scratch, you could say, and then so one of there's 6 total, so derive one of the 6 from scratch, and then the other 5 we can derive from that one that we found from scratch. And so what we're going to do is we're going to find an identity for cosine of a minus b, the difference identity for cosine. We're going to get this from scratch. What is this equal to? And then the other 5 we can just derive using this as the foundation. Okay, so to get the difference identity for cosine, we're going to start with the unit circle. Okay, so this has a radius of 1. Now, what we can think about is, let's make a terminal side with angle B. Okay. So this terminal side is at angle B, and it intersects the unit circle at point Q. Okay. Now, let's draw another terminal side just at some random position, but past B. We'll put that, let's say, here. You know, this isn't 90 degrees or anything. This is just a random position, but greater than B, and this is at angle A. And it intersects the unit circle at point S. Now, okay, I'll put in here's the initial side. Intersects the unit circle at point P. And then we're going to put another terminal side that has angle A minus B. So we're going from, the way we can think about it is you take A here and subtract B. So go back this amount. So we're about there. That is A minus B, intersecting the unit circle at point R. Okay? Now what we want to do is write the coordinates of each of these points on the unit circle. So point P is, the coordinates are 1, 0, right? Point Q, what about point Q? What are the coordinates of point Q? Well, we know that the unit circle definition of trig functions, one of the advantages is it makes the coordinates of points on the unit circle very convenient in terms of they're defined explicitly in terms of the actual trig functions. So if point Q is at angle B on the unit circle, then we know that its coordinates, its x coordinate is cosine of B, and its y coordinate is sine of B. Right? Similarly with point S, it's going to be at cosine of A, sine of A. And then point R is going to be at cosine of, the angle is A minus B, sine, then sine of A minus B. So okay, now next what we want to do is let's draw some chords between these 2 points. So let's draw a chord between point R and point P, and between point S and point Q. All right. Now, if you think about it, the central angles between these these radiuses. So this is the origin. So OR and OP, that central angle that the chord is, connected between, is going to be the exact same as the central angle between OS and OQ. In other words, this like ROP, those two sides, if you just rotate those rigidly, like you rotate this rigidly. In other words, without change, you don't change the angle between those two, and you can get to where it overlays exactly with OS and OQ. Meaning that the triangle OSQ and triangle ORP are equivalent triangles. One is just rotated relative to the other. And how do we know that? Well, you can tell to get OP to OQ. OP and OQ are the same length. It's the radius, length 1. To get OP to OQ, you rotate it B. Well, how much is this side rotated relative to this side? That's also B. So this is going to line up. OR is going to line up exactly with OS once you rotate OP B. So it's the same exact triangles. Therefore, chord SQ is congruent with chord RP. They're the exact same length. Okay. Now, we know the coordinates of the endpoints of those two lines, the two chord lines, line SQ and RP. We have the coordinates of those points. So we can use the distance formula from algebra to write the lengths of these chords, and we can set those lengths equal. So let's do that. All right, so the length of SQ will do, so x to this x minus this x squared, so cosine B minus cosine A squared plus, and then sine B minus sine A squared, and take the square root of all of that. There's the length of SQ. Now, what about the length of RP? Well, we'll do, let's see, cosine of A minus B minus 1 squared plus sine of A minus B minus 1 squared. Take the square root of all of that. Or no, sine of A minus B minus 0. Okay, let me create some more room here. All right. Now we want to square both sides. To get rid of the radicals, we're left with and then sine of A minus B is just, so sine squared of A minus B. All right, now let's expand these out. So, okay, this is going to be cosine squared of B minus cosine A cosine B minus cosine A cosine B, so minus 2 cosine A cosine B, and then plus cosine squared of A. And then we're going to have sine squared of B minus 2 sine A sine B plus sine squared of A. All right, then we'll have cosine squared of A minus B minus cosine A minus B minus cosine A minus B minus 2 cosine A minus B plus 1, and then plus sine squared A minus B. Okay, So now if we look, we can see we've got cosine squared of b plus sine squared of b. That's 1. So those go away, right? Pythagorean identity, sine squared plus cosine, sine squared of theta plus cosine squared of theta is equal to 1. We've got cosine squared of a plus sine squared of a. That's also 1. Then we're left with, so minus 2 cosine a cosine b minus 2 sine a sine b. Okay, now here you've got cosine squared a minus b plus sine squared a minus b. That's 1. Yeah, so we're done with these. All right, then plus 1, and then minus 2 cosine a minus b. Okay, now we can see we've got 1 plus 1 is 2. 1 plus 1 is 2, so positive 2 on both sides. Those subtract out. And so what we're left with is minus 2. Let's put this in front. Cosine a minus b is equal to minus 2 cosine a cosine b minus 2 sine a sine b. All right. Now we can divide both sides of this by minus 2, and we're left with cosine a minus b is equal to cosine a cosine b plus sine a sine b. And there you go. There it is. The difference identity for cosine. Cosine of a minus b is equal to cosine a cosine b plus sine a sine b. Okay, so now we have one of the 5 of the sum and difference identities, but this is the one we're going to use as the foundation to get all the other ones. So to get the sum identity for cosine, let's say that, let's plug in here into the difference identity. We're going to say that a is just equal to a, but b is equal to minus b. Okay? So if we do that, then what we get is cosine of a minus and then minus b, which is what? That's cosine of a plus b. All right? So that's equal to cosine a cosine minus b plus sine a sine minus b. Okay? So cosine of a plus b is equal to, we know that the even odd identities, and just the fact that we know cosine's an even function, tells us that cosine of minus b is just equal to cosine b. Okay, now sine of minus b, we know that from the even odd identities, or just the fact that we know that sine's an odd function, that sine of minus b is minus sine of b, so and there we go. There's the sum identity for cosine. All right. Now, next, let's get the sum identity for sine. So sine of a plus b. To do this, we start by using one of the cofunction identities that relates sine and cosine. Right? So we know that sine of theta, okay, if we write this out with its cofunction identity, the cofunction pair for sine is cosine, so sine of an angle is equal to cosine of a complementary angle. So we're trying to derive sine of a plus b, which, using this cofunction identity, is going to be equal to cosine of 90 degrees minus. Okay, and now what we want to do is let's distribute this minus sign. So that would be cosine of 90 minus a minus b. And now let's regroup this way. And so now we want to look at, if this is, let's say, x and this is y, then let's use the difference identity for cosine. We have cosine of x minus y. Let's expand this out with x being 90 minus a and y being b. So this gives cosine of 90 minus a. So it's cosine b plus sine 90 minus a sine b. Okay. So now cosine of 90 minus a, based on the cofunction identity, is sine a. So sine a cosine b. And then sine of 90 minus a is cosine a. So and there we go. Okay, now to get the difference identity for sine, we just do, we plug into sine of a plus b. We say a is equal to a and b is equal to minus b. So sine of a plus minus b, which is just sine of a minus b, is equal to, so sine of a plus cosine of a sine of minus b. All right, cosine of minus b, cosine's even function, so that's just, all right, sine of minus b, sine's an odd function. And there we go. Okay, now what about the sum and difference identities for tangent? So what we're going to do is use the quotient identity. So we know that tangent of a plus b is equal to sine of a plus b over cosine of a plus b. All right, now let's write out sine of a plus b using the sum identity for sine. So sine of a plus cosine a sine b, and then cosine of a plus b is cosine a cosine b minus sine a sine b. All right, now we want to multiply this by 1 in the form of, so 1 over cosine a cosine b over 1 over cosine a cosine b. And so you can think about what you'll get is, so we'll have sine a cosine b over cosine a cosine b. That's going to be sine a over cosine a. All right, and then plus cosine a sine b over cosine a cosine b. That's going to be sine B over cosine B. All right, now in the denominator, you'll have cosine A cosine B over cosine A cosine B. That's going to be 1. And then sine A sine B over cosine A cosine B. So let's just write that out. Sine A sine B over cosine A cosine B. Okay, now, so let me put, all right, now since the quotient identity, sine of x over cosine x is equal to tangent, we can write this as tangent A plus tangent B over 1 minus, and then we've got tangent A times tangent B. And there it is. There's the sum identity for tangent. Okay, now tangent A minus B, we just plug in the A is equal to A and B is equal to minus B into the sum identity for tangent. And we get, so tangent A plus tangent minus B all over 1 minus tangent A times tangent minus B. Now, okay, tangent is, the even odd identities tell us that tangent minus B is equal to minus tangent B. So tangent A minus tangent B over 1 plus tangent A tangent B. And there we go. There are the 6 sum and difference identities. They're for sine, cosine, and tangent.